Meganeuropsis was one of the largest flying insects ever known to have lived in Earth's history and inhabited the planet during the late stages of the Paleozoic era. Although its external appearance closely resembled that of modern dragonflies, it was not directly related to them from an evolutionary standpoint. Instead, Meganeuropsis belonged to a completely extinct and separate group of ancient insects. It was classified within the class Insecta and the phylum Arthropoda, and placed in the order Meganisoptera, also referred to in older literature as Protodonater. This order does not represent the direct ancestors of modern Odonater dragonflies and damselflies, but rather an independent evolutionary lineage that diverged from a very ancient common ancestor and developed in parallel. Meganeuropsis lived primarily during the early Permian period, approximately 299–272 million years ago. This interval represents the final phase of the Paleozoic era and was characterized by a generally warm and humid global climate, extensive wetlands, dense forested landscapes, and an unusually high concentration of atmospheric oxygen. These environmental conditions played a crucial role in the emergence of insect gigantism. During this time, atmospheric oxygen levels are estimated to have reached 30–35%, which significantly enhanced the efficiency of the tracheal respiratory system in insects and allowed them to sustain much larger body sizes than are possible today. The scientific study of Meganeuropsis began in the 20th century. Its most well-known species, Meganeuropsis permiana, was discovered in 1937 in lower Permian geological deposits in the state of Kansas, United States. The fossil material was scientifically described by the American paleoentomologist Frank Morton Carpenter, who was affiliated with Harvard University and regarded as one of the leading experts on fossil insects. The recovered specimens consist mainly of wing impressions and partial body fragments, and these remains formed the basis for reconstructing the insect's size, morphology, and overall appearance. Morphologically, Meganeuropsis was highly specialized for flight. It possessed a large head with extremely well-developed compound eyes, enabling it to detect moving prey over considerable distances. Its mandibles were robust and well-suited for a predatory lifestyle. The thorax was strong and heavily built, supporting powerful flight muscles. The wings were exceptionally large, transparent, and densely veined, providing substantial lift and aerodynamic stability. The body was elongated and dorsoventrally flattened, contributing to balance and maneuverability during flight. In terms of size, Meganeuropsis reached record-breaking dimensions among insects. Its wingspan typically measured between 71 and 75 centimeters, with some reconstructions suggesting values approaching 80 centimeters. The body length was approximately 43–45 centimeters, and its estimated mass ranged from 100 to 150 grams. These dimensions make Meganeuropsis widely recognized as the largest flying insect known from the fossil record. Ecologically, Meganeuropsis inhabited warm and humid environments such as wetlands, river margins, lakeshores, and dense tropical forests. In modern geographic terms, its known distribution corresponds mainly to central regions of what is now North America. It was an active aerial predator, likely feeding on other large insects, small amphibians, and early reptiles. Within its ecosystem, Meganeuropsis occupied one of the highest trophic levels in the aerial food web and appears to have had few, if any, natural competitors. The extinction of Meganeuropsis is closely linked to the profound environmental crises that occurred toward the end of the Permian period. Around 252 million years ago, the Permian Triassic mass extinction event eliminated a vast proportion of Earth's biodiversity. A significant decline in atmospheric oxygen levels, progressive cooling and drying of the climate, the loss of extensive wetland habitats, and major changes in vegetation severely disrupted ecosystems. These factors collectively rendered the survival of giant insects such as Meganeuropsis impossible. The genus did not undergo evolutionary transformation into another insect group and left no direct descendants. Instead, it represents a completely extinct evolutionary branch. Today, fossil remains of Meganeuropsis are housed in major scientific institutions in the United States, including the Harvard Museum of Comparative Zoology and the Smithsonian National Museum of Natural History. Contemporary research on Meganeuropsis involves high-resolution three-dimensional digital reconstructions, aerodynamic modeling of wing structure, reconstructions of Paleozoic atmospheric conditions, and broader investigations into the evolutionary mechanisms underlying insect gigantism. As a result, Meganeuropsis continues to serve as a key model organism in paleontology and paleoentomology, offering valuable insights into the limits of insect body size and the ecological dynamics of ancient terrestrial ecosystems.